Hello everyone, so today we are going to solve this LeetCode problem, which is minimum cost path with teleportation. What this question says is that we have been given a m cross n grid and an integer k. We have to start from the top left corner, which is 0, 0, and we have to reach the bottom right cell like this, m minus 1 and comma n minus 1. Okay, and what are the moves available? We can move from right or down to current cell, and the cost is the value of the destination cell. Suppose we see from this example, here our grid is given 1 3 3 2 5 4 and 4 3 5. This grid is given. Okay, so we have to move from this cell to this cell. Now we can move either down or right. Okay, so if we move from here to here, it will be 3. Then if we move from here till here, it will be plus 4, which is 7. Okay, then if we move from here to here, it will also be plus 3, which makes it 10. And finally here to here, 5. So it will be 50. But one more condition is given. What this condition says that we can teleport from I comma j cell to any of x comma j cell such that this cell is smaller than or smaller or equal to this cell. Suppose if we teleport from this cell to this cell, these are equal, then the cost would be 0. The cost to move this is 0. Okay, and we can move at most k time, this which our k have been given. Okay, so what can we do if we calculate all the moves in which our I comma j cell which are eligible for teleportation is greater than equal to our x comma y cell. Okay, then we can easily find our teleportation moves. Okay, so if we find our teleportation moves, then we can easily implement a dp, a general dp with the teleportation criteria. Okay, now let's see with the help of solution how we can solve this. Okay, first what is given, we have been given a grid and a integer k. This have been given. Okay, so first we'll find the size of our grid. This would be number of rows, and this will give us our number of columns. Okay, then we can find our total number of cells in the grid, uh, m comma n, which will be equal to m into n. Okay, then what we'll do, we'll store all these pair in a vector. Okay, why we will taking, because our teleportation has one condition, which is the grid of I comma j should be greater than I comma x comma y. So for this we are taking this grid order. Okay, and we'll reverse this to avoid any repetition of memory allocation. Okay, now we'll fill this grid order. How we'll fill this? We'll add every cell r is equals to 0 and traverse through the rows plus r. Okay, and similarly for the columns is equals to j, c less than number of columns plus c. Then what we'll do, we'll push back these in our grid order. This will give us the grid value. Now we need to sort this grid value in a descending order. Okay, then we'll simply sort these cells in decreasing order. Node begin, comma, grid order dot end. And what is the condition? We have to sort them not in increasing order but in decreasing order. Okay, each pair. Therefore we say we'll return grid of a dot first and a dot second should be greater than grid of b dot first and b dot second. This is a simple lambda which compares the two coordinates, and this is the very important for our teleportation logic. Okay, now we'll define our dp grid, which will give us the minimum cost. Okay, we'll define it as cost only, and it will give us our minimum number of array. Okay, we have initialized it with a very large number. Okay, now what we'll do, we start with the logic for our traversal to the grid. Now we'll define our loop, and we'll repeat this process until we are allowed with our k variable. Okay, that is number of the time the teleportation is allowed. Okay, for each iteration one more teleport is allowed. Okay, that is in l equal to 0, r equal to 0. We will define these are sliding window pointers to track the minimum cost among equal valued cells. Okay, now we'll apply this logic in our sorted cells. While r is greater than m comma n and our grid of grid order of r dot first grid order of r dot second means we are finding the value where these two are equal, so that we can easily process the teleportation logic where the grid values are equal. Okay, if this is so, what we'll do, we'll track the cheapest way to range the cost, which is minimum cost is equal to minimum of min cost comma cost of grid order of r dot first and grid order of r dot second. Okay, now we'll simply apply the teleportation, that is for in I equal to l, I less than r, I plus plus, then our cost of grid order of I dot first from where we are coming and grid order of I dot second from where we are going. Okay, will be equal to min of cost, and then all the same value cells will be updated to minimum cost. Okay, now we move forward our window. Okay, then we'll try the normal moves. Okay, how we'll track for in r equal to 0, r less than m plus plus r, like we'll iterate through the grid tree P, and for int c equal to 0, c less than n plus plus c. Now we move from top. If r not equal to 0, then cost of r and c is equals to minimum of cost of r comma c comma grid of r of c plus cost of r minus 1 and c. And similarly we'll move from left. If c is not equal to 0, cost of r c is equals to minimum of cost of r of c comma grid of r of c plus cost of r of c minus 1. Okay, and simply then we return our answer, which will be getting in the last cell of our dp grid, which is m minus 1 comma n minus 1. Let's look through the entire problem what we have done. Okay, quickly. What we have done is our grid nrk was given. We have taken two variables to store the number of rows and the number of columns of our grid. Then we have taken the mn to find the number of cells in our grid which have been given. Then we have defined a vector pair grid order to maintain our teleportation logic. Okay, this helped with our teleportation logic. What we have done, we have done to just optimize our memory location. Then we have put all these columns and cells in our row, and we have sorted in decreasing order because our condition was given for teleportation that the cell from where we are coming should be greater or equal to the cell where we are going. This should be greater. Okay, then we have defined our dp grid cost. Okay, then we have firstly implemented a teleportation loop. Okay, in which we have applied a sliding window logic. Okay, where we have moved from the grid at most k times. Okay, at most k times which was have been given, and we tried for the teleportation moves first. Okay, from the big grid to the small grid, from the big grid to the small grid. Okay, and we find the minimum cost to the traversal through the our minimum cost from our teleportation logic. Okay, and at last we got that. Then what we have implemented our dp logic, which was our usual dp logic. We have iterated through the grid, and we have implemented simple logic firstly after computing all the teleportation logic initially. This has given us our answer in our dp m-1 and n-1. Hope you have understood this problem. This was a little tricky problem, but it was easy if you know the teleportation logic and you understood how the teleportation logic has been implemented. If you have any doubts, put it in the comment section.